Hello, ladies and gentlemen. Welcome to Math 20-2, Chapter 1, Section 5, Invalid Proofs, Part 1. Now, the outcomes today, we're going to explain why inductive reasoning may lead to a false conjecture, determine if a given argument is valid and justify the reasoning, and identify errors in a given proof. So, what is the error in this deduction? People over 21 are eligible to vote in Alberta elections. Corbyn is over 21. Therefore, Corbyn will vote in the next Alberta election. Well, the big error I see voting is a privilege, is a right, but is not mandatory. He has the choice to vote or not. That's one error. Now, of course, the next question is, does he live in Alberta? If you think about it, is he a Canadian citizen? Yes, you have to be a Canadian citizen. You have to live in Alberta for 6 months or a year before you can vote. And even if you have the right to vote, it's a choice, which is actually unfortunate, but this is another story. Now, what is the error in this deduction? Athletes do not compete in both the Summer and Winter Olympics in the same year. Hayley Wickenheiser has represented Canada 4 times at the Winter Olympics. Therefore, Hayley Wickenheiser has not participated in the Summer Olympics. Well, the problem with that is she played softball in the Summer Olympics. So, I think the error is here. Do not compete in both the Summer Olympics in the same year. Oh, so she definitely has competed in the Summer and Winter Olympics. Right? Now, which of the following calculations are invalid or wrong? So grab a calculator and start punching these numbers in. Which ones do not work? Well, minus 28 over 7 is minus 4, which is fine. Square root of 36 is 6. Let's see, the square root of minus 16 does not work. You get an error when you put that in your calculator. At least I did. Now, actually, pause the recording and do these. We'll come back and compare our results. So pause the recording. Pause it. Welcome back. Now, when I did these, some I was able to simplify. And you'll see here. Sorry, I shouldn't circle them. What was I? Yes. This one works. Square root of 36 works. Cube root of 8 is 2. The cube root of minus 64 is minus 4. And yes, square root of 5 squared minus 4 squared is square root of 16, 25 minus 16, which is square root of 9, which is 3, which works. What doesn't work? Well, as we figured out earlier, the square root of minus 16, you can't take the square root of a number, of a negative number. You can take the cube root of a negative number, which is confusing. Now, 14 divided by 0, you can't divide by 0, you get error on your calculator. Now, same thing with this, 12 divided by bracket 3 squared minus 9. You have to do order of operations, BEDMAS, brackets, exponents, multiplication, division. So that becomes, inside the brackets, 3 squared is 9, 9 minus 9 is 0. 12 divided by 0 doesn't work. And oh, this one here, square root of 25 minus 36, that's square root of minus 9. You can't take the square root of a negative number, but I already came up with one of those. So, minus 36. Oh, sorry, that's minus 11, not minus 9. Forgive me, ladies and gentlemen. I hate this getting old. Where's the eraser? Eraser. 25 minus 36 is square root of minus 11. Barakazad, I mean you, and I meant that. Anyway, so invalid, or, sorry, better word might be don't work. So that's what we're looking at here. Proofs that don't work. So complete the statements about invalid calculations. Okay. It is invalid to divide by 0. You cannot divide by 0. An example? Well, we just had one right back here. 14 divided by 0. Grab Mr. Calculator, do it again. Anything divided by 0. And it does not work. So, and it's invalid to find the square root of a negative number. An example, we just did that back here, square root of minus 16. Okay, so that's stuff you got to know. Okay, so what's the error in this deduction? So we have a proof here that there's something wrong. We have to figure it out. So I'm saying a plus b equals c. No, I'm not saying what a is and what b is. Just a plus b is c. Okay. Now, if I go 4 times 3, actually I should say it's not as clear as it could be. If I multiply both sides by 4 minus 3, I get 4a minus 3a plus 4b minus 3b equals 4c minus 3c. Now, if I put all the 4's on one side, so I subtract 4c both sides, I add 3b to both sides, and add 3a to both sides, so I get all the 3's on one side. I get this, 4a plus 4b minus 4c equals 3a plus 3b minus 3c. Then I factor 4 from the left and 3 from the right. So it's 4 bracket a plus b minus c, close bracket, equals 3 bracket a plus b minus c, close bracket. Then I divide both sides by a plus b minus c, and I get 4 equals 3. Now, what's going on here? 4 doesn't equal 3. So I made a boo-boo somewhere. What happened? Well, if you look at it and think about it for a few minutes, it's kind of difficult. But notice here I'm dividing by a plus b minus c. We go back up here. A plus b equals c. That means a plus b, subtract c from both sides, minus c equals 0. And what are we doing here? Dividing by 0. That's wrong. We cannot divide by 0. When we do that, bad things happen. It doesn't work. The technical definition of that is an invalid proof. A proof that contains an error in reasoning or contains invalid assumptions. Okay, now, I need you to put this definition in your own words. So, invalid proof, where there's an error, okay, there's a mistake, in the proof, so it does not work. So it is not true. Okay, so your proof doesn't work, which sucks. All right? Now, I'm going to pause the recording here. I want you to look at this and think about this a little bit. If you've got it, great. Go on and watch the next video. If not, shoot me an email or see me in class. Good luck. Good luck.